So if I have, say, a little ball here, and I displace it by a certain distance in that direction, okay, so that it comes here, and then I displace it by another distance in another direction, and the ball comes there, then I can understand that the resultant displacement is simply this. I can think of the resultant displacement as a vector joining directly the starting and the end position, right, with this distance and this direction, right? But then we have seen that there are examples of other vectors, like say the velocity vector. Okay, velocity vector. So what if I now want to think of think about the velocity of the ball? Now, what does it mean if I have a velocity vector? Well, it can mean something quite similar. If I say I have a velocity vector like that, it could mean instead of say moving by some meters, it would be the magnitude would be a speed, like maybe 5 meters per second, right? So there's a time involved, per second involved. Now, but what does it mean if I want to add two of these vectors, right, with a certain magnitude and direction? Does it mean that the ball, we must wait for the ball to move some distance from there to there, and then we have another velocity in another direction, and then? Well, not really. If we have two velocities, let's say one velocity this way, and if we can just imagine for the moment, if I have another velocity, say that way, okay, with say a size of maybe 3 meters per second, but in another direction. Well, adding velocity vectors usually means that the two velocity vectors, happen at the same time. So what does it mean, two velocities happening at the same time? That's the tricky parts of vector addition here. Now, let's try to imagine one situation. Well, it's simple enough to think of a ball either moving in that direction with a certain speed or in this other direction with a certain speed. But what does it mean if it has the two velocity vectors or two velocities at the same time? Let's imagine a situation, right? What situation is that? Now, okay, let me add something to this. Now, suppose that we are by the river. Okay, so that's the side of a river. One side of a river. That's another side of a river. Okay, another side. And all right, so there is let's see, there is a boy standing there. Okay, and this boy dropped the ball on, or he threw the ball into the stream. Right, so this is a stream. Okay, there's water, water here, water, lots of water. Okay, so lots of water. We have a nice little stream there. Now let's look at these velocities now. Suppose this arrow here represents this 5 meters per second represent the speed and the direction of the river, of the water flowing along this direction. Okay, and this other arrow, 3 meters per second, represents the speed that the boy threw the ball into the river. So suppose that the boy threw the ball in this direction, and so the ball would start moving along this direction with the speed of 3 meters per second, but at the same time it is being pushed along the river in this direction at a speed of 5 meters per second. So in this way, we can actually have a real situation in which there are two velocities acting on the ball at the same time. Its own velocity this way, and the velocity as it gets dragged along by the river. Now in this case, we might just imagine that the actual movement of the ball would neither be in its original direction that the boy threw into the river, nor the direction of the water itself. It would probably be somewhere in between. Okay. Now, exactly which way in between? Well, let's try to imagine this situation. Now, suppose that if we think of what happens if either of this velocity vector is not there. Suppose that we can turn off the river, okay, turn off the motion of the river, and the ball is just moving along this direction at 3 meters per second. So suppose after say let's draw something. Suppose after a few seconds, the ball with the river switched off, the ball moves along this direction. Okay, let's try and draw this. The ball moves this way. Alright, after a few seconds. Now, let's say let's talk about say 1 second. Okay, so let's say that's 1 second. After 1 second, the ball will move 3 meters in this direction. Okay. Now, suppose that instead of throwing the boy just drops the ball here, so that the boy just drops the ball so that this velocity is not there, and instead we now switch on the water, the flowing water, so that the ball moves along in this direction. Then after 1 second, okay, the ball would move. Let's see. The ball would move along this direction after 1 second by 5 meters. Alright. Now, but what if we now have both the river flowing and the boy throwing the ball in the river? Well, the ball would move after 1 second. The ball would both move in this direction, the direction of throw, and it would also be pulled along the river in the other direction by 5 meters. So it's as if there's a combination of travel after 1 second of this distance, okay, by maybe 3 meters, and this distance by 5 meters. So we might imagine that there is a simultaneous motion in the two directions. Okay, both along the original direction and along here. Along here by 5 meters. So the end effect is that the ball would move in this direction. Okay, now how can we determine this direction? Now, if I just complete this figure, you can see that this would actually be a parallelogram. Okay, that's the distance. You have distance moving. This is the distance moving 1 second here. That's the distance moving 1 second. If it's just the river, and that's the distance moved in 1 second if the river is not there. Alright, so we see that there's a parallelogram down here. So this gives us a way of determining the direction. Okay, if we go back to our original vector, you can just imagine that we complete using the two original vectors as the sides, we draw a parallelogram around it. Okay, then this vector, this diagonal, would then give us the combined effects of the two velocities. So this would give us the resultant velocity down here. Okay. Now using a similar notations that we use for displacement, I could, let's see, let me call this vector A. Let me call this vector B. Okay, and let me call this vector, let's see, vector C for the diagonal. So therefore, I can say that A vector plus B vector is equal to C vector.